The greenhouse effect simulation is an interactive educational tool designed to help students understand the principles and impacts of the greenhouse effect on Earth's climate. By providing a hands on approach to exploring the interactions between greenhouse gases, infrared waves, and surface temperature, the simulation offers a comprehensive learning experience that covers the fundamental concepts of the greenhouse effect. The simulation is divided into several parts: the waves part, the photons part, and the layer model part, each offering unique insights into different aspects of the greenhouse effect. The waves part of the simulation allows students to adjust the concentration of greenhouse gases and observe the effects on infrared waves and surface temperature. Greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, absorb infrared radiation emitted by the Earth's surface, trapping heat in the atmosphere. By increasing or decreasing the concentration of greenhouse gases, students can observe how the infrared waves are absorbed and re-emitted by the atmosphere. Higher concentrations of greenhouse gases result in more infrared radiation being trapped, leading to an increase in surface temperature. This interactive feature helps students understand the direct relationship between greenhouse gas concentration and global warming. Students can measure the energy balance at the top of the atmosphere. The energy balance is the difference between the incoming solar radiation and the outgoing infrared radiation. A positive energy balance indicates that more energy is being absorbed by the Earth than is being emitted, leading to a warming of the planet. By adjusting the greenhouse gas concentration and observing the energy balance, students can gain insights into the mechanisms driving climate change. The photons part of the simulation allows students to observe sunlight and infrared energy represented as photons. Sunlight, primarily in the visible and ultraviolet spectrum, is absorbed by the Earth's surface and re-emitted as infrared radiation. This infrared energy is then absorbed by greenhouse gases in the atmosphere. Students can experiment with different concentrations of greenhouse gases and observe how they affect the behavior of photons throughout the atmosphere. Higher concentrations of greenhouse gases result in more photons being absorbed and re-emitted, leading to an increase in the energy flux within the atmosphere. This interactive feature helps students understand the role of greenhouse gases in trapping heat and regulating the Earth's temperature. Students can measure the energy flux throughout the atmosphere. Energy flux is the rate at which energy is transferred through a given area. By observing the energy flux at different levels of the atmosphere, students can gain insights into how energy is distributed and how it contributes to the overall energy balance of the Earth. The layer model part of the simulation allows students to model greenhouse gases as infrared absorbing layers. By controlling the solar intensity, surface albedo, and infrared absorbance, students can observe the impact of these factors on photon behavior and the temperature of the atmosphere. Solar intensity refers to the amount of solar radiation reaching the Earth's surface. By adjusting the solar intensity, students can observe how changes in solar radiation affect the energy balance and the temperature of the atmosphere. Higher solar intensity results in more energy being absorbed by the Earth, leading to an increase in temperature. Surface albedo is the reflectivity of the Earth's surface. Different surfaces, such as ice, water, and land, have different albedos. By adjusting the surface albedo, students can observe how changes in reflectivity affect the energy balance and the temperature of the atmosphere. Higher albedo results in more solar radiation being reflected back into space, leading to a cooling effect. Infrared absorbance refers to the ability of greenhouse gases to absorb infrared radiation. By adjusting the infrared absorbance, students can observe how changes in the concentration of greenhouse gases affect the energy balance and the temperature of the atmosphere. Higher infrared absorbance results in more infrared radiation being trapped, leading to an increase in temperature. The simulation provides an interactive platform where students can actively engage with the concepts of the greenhouse effect. By adjusting various parameters and observing the results, students can gain a deeper understanding of the mechanisms driving climate change. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the behavior of infrared waves, photons, and the energy balance in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation covers a wide range of topics related to the greenhouse effect, including infrared waves, photon behavior, energy balance, and the impact of greenhouse gases. This comprehensive approach helps students gain a holistic understanding of the greenhouse effect and its implications for the Earth's climate. The greenhouse effect simulation is a valuable tool for teaching and learning about the principles and impacts of the greenhouse effect on Earth's climate. By providing an interactive, visual, and comprehensive platform, it helps students understand the fundamental concepts of the greenhouse effect, including the role of greenhouse gases, infrared waves, and energy balance. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in climate science. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating interactions between the Earth's atmosphere and its climate.